Bismillahirrahmanirrahim. This is my second presentation, which is presented to Sir Hammad Majeed and presented by Sehar. My ID is 2100406708 and my course is Principles of Chemistry 1. Today's my topic is about phosphoric acid and phosphorus acid. We will discuss about its structure and shape based on chemical bonding theories. Firstly, we will discuss about phosphoric acid. Phosphoric acid, also known as orthophosphoric acid or phosphoric acid, is a weak acid. Its formula is H3PO4 and molar mass is 97.994 gram per mole. Its density is 1.88 gram per cubic centimeter. Then we will discuss about phosphorus acid. Phosphorus acid, also called orthophosphorus acid, one of several oxygen acids of phosphorus, used as reducing agent in chemical analysis. It is a colorless or yellowish crystalline substance with a gristle-like taste. Its formula is H3PO3 and the molar mass is 82 gram per mole and density is 1.65 gram per cubic centimeter. Then we will discuss about its level structure. Firstly, for phosphoric acid, H3PO4 is the formula of the phosphoric acid, and in this hydrogen has one valence electron, and it will be multiplied by 3 because in this structure hydrogen has 3 atoms. Next, phosphorus has 5 valence electrons and oxygen has 6 valence electrons. We will multiply it by 4 because there are 4 oxygen atoms. Next, we will discuss about steps for drying. Firstly, count all the valence electrons. The second point is determine the central atom, and there the central atom is phosphorus. Third point is draw single bonds to the central atom. And the fourth point is pull all remaining valence electrons on atoms as lone pairs. And fifth point is turn lone pairs into double or triple bonds to give every atom on octet. Next, moving to the next slide, we will discuss the phosphorus acid. Phosphorus acid has the formula is H3PO3. There hydrogen has one valence electron. We will multiply it by 3 because in this structure there are 3 hydrogen atoms. Next, phosphorus has 5 valence electrons and oxygen has 6 valence electrons. We will multiply it by 3 because in this structure there are 3 oxygen atoms. Next, we will discuss about their steps for drying structure of phosphorus acid, which are: firstly, find total number of electrons of the valence shells of the phosphorus, oxygen and hydrogen. Next, total electron pairs. And third point is center atom selection. Fourth point is put lone pairs on atoms. Next is check the stability and minimize charges on atoms by converting lone pairs to bonds until most stable structure is obtained. And next, there is given the shapes of shape of phosphoric acid given below as valence bond theory. The types: there are 2 types of bonds that we consider in valence bond theory. First, the sigma bond, and the second is the pi bond. Sigma bonds are skeletal bonds. They hold molecules together and are stronger than pi bonds. Pi bonds represent multiple bonds. They consist of a sigma bond and pi orbital overlap. Next, this structure VBT. There are given phosphoric acid and phosphorus acid, which have structure of VBT. Moving to the next slide, we will discuss about Vesper theory. Steps for structures according to Vesper theory. First point is maximum electron pair repulsion between lone pair and bond pair. Next point is electron pair are always repelling other. And the third point is different electron pairs have different order of repulsion. Lone pair uh, lone pair is greater than lone pair minus bond pair is greater than bond pair minus bond pair. Lone pair is 0, then geometric and shape will be same, otherwise geometric will be different for shape. Geometry depend upon bond pair and lone pair. If z is equal to 2, and the geometry will be linear. If z is equal to 3, the geometry will be trigonal planar. If there is z equal to 4, the geometry will be tetrahedral. If z is equal to 5, the geometry will be trigonal pyramidal. If z is equal to 6, the geometry will be octahedral. And shapes depend upon surrounding atoms. Then we discuss about limitations of Vesper theory. Some significant limitations of Vesper theory include: this theory fails to explain shapes of the isoelectronic species. This means that its element having same number of electrons. Vesper theory doesn't explain these species. This theory is only successful for period number 2 elements. This theory only works for small size molecules. The Vesper theory does not shed any light on the compounds of transition metals. And the last point is, another limitation of Vesper theory is that it predicts that halides of group 2 elements will have a linear structure, whereas their actual structure is a bent one. Next, we can see that there is a structure of phosphoric acid. By following the formula, z is equal to 1 by 2 into 5 plus 3 plus 0 plus 0. There is 5 represent to phosphorus electrons and 3 represent to hydrogen electrons, and there is no removal and addition. We will add 0 plus 0 and 0. Then Bp is equal to, B means bond pair is equal to 1 by 2 into 4 by 8. Bp is equal to 4. We obtain bond pair. Next, linear pair is equal to Z minus surrounded atom. There Z is equal to Z represent to 4 and surrounded atom represent to 4. Linear pair is equal to 0. Next is H3PO4. There is a given structure. We will discuss about next hybridization. This step, there are different steps for drawing structures. Firstly, same valence electrons with same or nearly same energy. Next point is degenerate orbital have same energy and shape. And the next point is we will discuss about the steps for the steps for drawing structure. The step is central atom involved hybridization. And the next point, moving to next slide, is half filled, empty, fully filled, all are involved in hybridization. Next, number of orbital equal to the number of intermixing orbital. And the next is pi bond is not involved in hybridization, only sigma bond is involved. And the next and last is not by least is hybrid orbitals, or according name of parental orbital. The shape of hybrid is different from parental orbital. Repulsion is maximum, distance is maximum, then geometric rate. If z is equal to 2, the hybridization will be sp. If there is z is equal to 3, the hybridization will be sp square. If there is z is equal to 4, the hybridization will be sp3. If Z is equal to 5, the hybridization will be sp3 into D. If Z is equal to 6, the hybridization will be sp3D square. And if Z is equal to 7, the hybridization will be sp3D3. Thanks for watching this video. Allah Hafiz.